For today's lecture, I want to continue with Unit 3 with the I/O management and really look into the Java.io package and kind of analyze the API that's made available to us. So I'd like to pick up with looking at the pushback input stream. So a quick overview for this section is I want to do a quick introduction to what the pushback input stream is. And then take a look at its class declaration so that we can see its hierarchy, what it effectively is implementing off of. That'll give us an idea of what methods it's inheriting from and what memberships it's a part of. We'll look at the constructors, we'll look at the methods that we want to talk about, and then we'll look at some actual code examples, because I think that's always the most meaningful part of these quick little presentations into each one of these classes within inside of the IO package. So quick introduction to this particular class. The pushback input stream in Java is an input stream. So recall that these streams are all the byte streams. So this particular one can push or return back a single byte or character back into the input stream so it can be reread. So in other words, the pushback input stream is a buffer stream that adds pushback functionality to an input stream so that we can go ahead and reread unread bytes that are still in the stream, push those back onto the stream. And so that gives us what we'll call a pushback buffer. It is used on an input stream to allow a byte to be read and then returned back to the stream. So for example, suppose that we had an input stream that contains the string of bytes LOVE, love. If we read 2 bytes, we would have read LO. If we call unread, the unread method of the pushback input stream to push back the last byte that we have read, then the subsequent read will return O to the next reads, and then it'll read V and E. So a quick look at just the class declaration. So we have our pushback input stream. It's a concrete subclass, so we can actually instantiate off of it. It's a subclass of the filter input stream because it adds functionality on a pre-existing input stream. So recall anytime that we're having to pass one stream into another to get additional functionality, those all have the membership to the filter input stream class. And so the filter input stream class itself extends the mother of all of the input streams, which is the input stream. It also implements closable and auto closable. All of them should do that. Those are interfaces. Those contain function definitions, method definitions that all input streams should have. The general syntax to declare the pushback input stream class would be, well, it's a concrete class, so it'd be public class and then pushback input stream. And then it extends, as we said, the filtered input stream. And then that is going to, and then it also implements closable and auto closable. So the pushback input stream class was added all the way back in Java 1, and it's present in the Java.io package. It's under pushback input stream. So let's take a look at some of the constructors for the pushback input stream. There is 2 that I want to take a look at. You have the pushback input stream constructor that takes in an input stream. Again, we need to create an input stream and pass it in to get that additional functionality. This form of the constructor creates a pushback input stream object that allows 1 byte to be returned to the input stream. We also have another constructor that has 2 parameters where we can pass in an input stream object and also an integer value that represents the number of bytes. And so this allows multiple bytes to be returned back to the input stream. So pretty simple constructors there. So some of the methods, in addition to the methods that are inherited from the filter input stream and input stream classes, pushback input stream also defines several important methods that are unique in and of itself to this particular subclass. So let's take a look at some of those, or at least the critical ones. Some of them are common, but some of them might be unique to this particular class. So they have the available method, which returns back an integer. This method returns an actual number of bytes that can be read or skipped over from the underlying input stream without blocking by the next invocation of a method. And so if this input stream is closed by invoking this close method, or an IO error occurs, it's going to return an IO exception, which pretty common. Also, we have the close method, supercritical method. We should always close our resources because it allows us to release any of the system resources associated with that underlying input stream. The close method does throw an IO exception if some kind of IO error occurs. We have a mark method where we can pass in an int value, a parameter as an int that will be our read limit. So this just method marks the current position in our stream. We can also check to see if mark is supported. The method examines if the input stream supports the mark and reset methods, and true or false if it does or doesn't, Boolean value returned. We have a read method. So this method reads the next byte of data from the underlying input stream. Recall that bytes can be represented as an integer value between 0 to 255. So we return back an int, and that also allows us to return back the value of a -1 to illustrate that we hit the end of the stream and that there's nothing more to go ahead and pull from it. And so if the input stream is closed while trying to invoke this method, it can create an IO error or an IO exception that can occur. We have an overloaded version of the read method here where we can pass in a byte array along with a offset and a number of bytes that we want to read. So this will read up to m bytes of data from the input stream into our byte array, starting at the index n that we give. And then we have the ability to skip where we can pass in a long integer value. And so this method just skips over and discards the bytes, the n number of bytes of data from the underlying input stream. So a lot of these we've already seen before in the other streams, but here we have some new methods that are unique to the pushback input stream. It's the unread method. So it's overloaded in 3 different ways. We'll go over each one of them. We have unread where we can pass in a byte array. So this method pushes back an array of bytes by copying it to the front of the pushback buffer. We also have the unread method where we can pass in essentially a subsection of the array, right? We could pass in a byte array. We can pass in our offset and the number of bytes that we wanted to go ahead and unread. And so here it pushes back m bytes of the array of bytes b, starting from the nth byte, and then it copies it to the front of the pushback buffer. And then finally, we have just an unread with a integer value. And so this method just pushes back a single byte by copying it to the front of the pushback buffer. So just like we had looked at buffered input streams and buffered output streams, pushback has a different type of buffer where we can push bytes back into it. Note that all of the above 3 unread methods throw an IO exception if there is no sufficient room in the pushback buffer, i.e. if the pushback buffer is full for the specified byte, or this input stream has been closed by calling this close method. Excellent. Okay, let's take a look at some of the examples here. So for example 1, let's try to read some data from a file. So we'll make a sample program where we'll try to understand how to use the pushback input stream effectively to unread bytes to the input stream and reread them. So in this example, we will read I love Java programming from the myfile.txt and then look at the source code to better understand that. So this is our source code here, but what I'm going to do is we're going to go into our IntelliJ. So instead of just looking at a static slide, we can walk through and actually run our code and see what the results are. So here I'm going to open up my pushback input stream tester. And I'm going to run this right now so that I'll have the output. so I can talk about it. And so here I'm going to start walking through the code. So the first things we're going to do here is we're going to go ahead and import file input stream, because we need a file input stream to pass into our pushback input stream, right? Because it's a filtered input stream. So we have to wrap a file input stream around it, or we got to wrap the pushback input stream around the file input stream. We're also going to go ahead and import our pushback input stream, our concrete class there. We'll also import IO exception. We're just going to throw that instead of using the try catch blocks, just to minimize the vertical size of my code, but typically you'd prefer to use the try catch block. I'm going to create a class that can have a main method. My main method is going to throw this IO exception so that I can just have all my code here, so I can easily walk through it. Here, I'm going to create my file path just as a string. So it's going to be my file.txt inside the src, inside the source directory, inside of my IntelliJ project. Now, what I'm going to do is create a new file input stream object using the file path. And I'm going to save a reference of that. And now that I have a file input stream reference, I can pass that to the constructor of the pushback input stream and build the pushback input stream around that file input stream. And that's going to allow it to have that pushback buffer capabilities. So now let's test this out. I'm going to create a little local variable here of a data type byte called byte data. And I'm going to create a while loop that will allow me to go ahead while my byte data here, right? While I'm going to read from my pushback input stream. So this is my pushback input stream. So I'm going to continually read from my pushback input stream. And so long as the result isn't a -1, which means that I still have something inside of the stream, I will bind the value to this byte data variable. And I'll also cast it into a byte. So recall that when we read, it's the default value is an integer value, right? So here I'm going to cast it into a byte. And then I'm going to go ahead and I'm going to cast that byte into a character so I can go ahead and print it out. And then after I print it out, I'm going to unread that byte data, which is as a byte. And remember, that's what we're operating on. And then what I'll do is I will then go ahead and read again that byte data, and then I'll go ahead and print it out again. And so what you're going to see, because of this, because I'm reading, then I'm unreading, and then reading again, the results of, okay, let me go back here. Let's see what this current state of my file.txt is. So the innards of this is actually welcome to UNO computer science. I must have overwritten it at some point in one of my other examples. So the contents of this is welcome to UNO computer science. So here we're going to read, unread, and read each character again and again. So you see we get double W's, double E, double L. Each instance of the characters are going to repeat twice. And that's what that is the power that the pushback input stream allows for us, to be able to read data and then insert it back in and then reread it if we need to. Excellent. And so really, there's not much I wanted to go into this, just a quick, brief overview. So if you encounter a problem where for any reason you need to pull data and then push back into the stream, understand that there is a class that has that functionality. So if there's no questions regarding this, I'll move on to one of the next stream classes that we can discuss.